Okay, so I just want to pick up from where we left off in class, where I was trying to finish the difficult algebra in this question. I made some kind of mistake near the end. I think I made a sign mistake on one side, and we'll see that as I go and do the solution again, hopefully without any mistakes. But I suppose the key is that for the tidying up part of the algebra, that's going to be worth maximum 5 marks in the exam. So not to spend too long on it, you're trying to get this value d equals 2e squared y over 1 plus e squared. But if you don't get that on the first go, but you're happy that your method is pretty good, leave it, move on and do the other questions that are going to be worth a lot more marks. And then if you have time at the end of the exam, come back and then obviously you can try and perfect your answer and get what they're looking for. So we found these 3 speeds already. So the speed of A after the first collision, the speed of B after the first collision, which is his speed into the wall, and then the speed of B coming off the wall, so where we apply the minus e to that speed. Now what we're going to do is, the theory here is that the time taken for A here to travel the distance of y minus d to where the second collision takes place is equal to the time taken for B to hit the wall and come, which is a distance of y, and then to come back and collide again with A, another distance of d. So the sum of those 2 times. So remember that time is equal to distance over speed. And so for the speed of A, we have u over 2 on 1 minus e, and the distance traveled is y minus d. So y minus d over u over 2 on 1 minus e. And you'll note that I'm just using u over 2. I had used the variable u1, but then realized later that there was no u2 in the question, so u would have been sufficient here. So that's the time taken for A to travel the distance of y minus d. That should be equal to the time taken for B to travel a distance of y at a speed of u over 2 on 1 plus e, plus a distance of d at a speed of e on u over 2 on 1 plus e. Now, I know that the actual velocity of B from the wall is minus e, because it's now moving to the left, but because we're looking for a time is just distance over the speed, and the magnitude of the speed is plus e on u over 2 on 1 plus e. At this stage we could divide across or multiply across by u over 2 to cancel all of those. And then I'm going to find a common denominator. Now you'll see in the printed solution that I find a common denominator on the right and then later combine that by cross multiplying. But here I'm just going to find a common denominator of all 3 denominators, and that common denominator is e on 1 minus e on 1 plus e. All of the denominators go into this common denominator. So if I divide 1 minus e into e on 1 minus e on 1 plus e, I get e on 1 plus e. So I'm going to multiply y minus d by e by 1 plus e. And that's equal to, if I divide 1 plus e into e on 1 minus e on 1 plus e, I get e on 1 minus e. So I'm going to multiply y by e by 1 minus e. And then if I divide e on 1 plus e into e on 1 minus e on 1 plus e, I get 1 minus e. So I'm going to multiply d by 1 minus e. Now when there's an equals on top, you can get rid of the denominator. The other thing I'm going to do is I'm just going to tidy up this piece here. So e times 1 is e, and e times e is e squared, and just multiply these 2 brackets together. Similarly, I could multiply y by e and just have ye. It just makes it a little bit more easy as we do the multiplication on the next line. So opening this bracket and multiplying it out, we have y by e is ye. We have y by e squared is ye squared. We have minus d by e, which is minus de, and minus d by e squared, which is minus de squared. And that's going to be equal to ye by 1, which is ye by minus e, which is minus ye squared, and then d by 1, which is d, and d by minus e, which is minus de. Now, a lot of terms cancel on the left and right, so we have ye on the left cancels with a ye on the right. We have a minus de on the left cancels with a minus de on the right. Now, I was going too quickly in class, the bell was coming up on me, and I cancelled those 2, and that's why I didn't get to the right solution. So obviously there's a plus on one side and a minus on the other side, so they obviously don't cancel. I'm trying to get d on its own, so what I'm going to do is I'm going to bring the d's to the right hand side, and I already have a d over here, so that's going to stay there. and then I am going to add a dE squared to both sides to get rid of it from the left. So we have plus dE squared. And I'm going to collect the ye squared on the left, and then add a ye squared to both sides to get rid of the minus ye squared on the right. Ye squared and ye squared is 2ye squared, and that's equal to d plus dE squared. I'm trying to get, again, d on its own, so I'm going to factorize the d. So I have d on 1 plus e squared, and that's equal to 2. Now it is ye squared, but in the solution it has e squared y, so I'm just going to switch that around. And then finally, to get d on its own, I'm going to divide both sides by 1 plus e squared, so I get 2e squared y over 1 plus e squared, and that's the solution.